Welcome to Quality and Welding Methodology. Plasma welding. It is plasma welding configuration. Plasma arc welding PAW process provides a very stable heat source for welding most metal from 0.001 to 0.25 inch, 0.02 to 6 mm. This process has advantage over other open arc welding process such as SMAW. GMAW and GTAW because has greater energy concentration in improved arc stability, higher current and higher welding speed. As a result, PAW has greater penetration capability than SMAW, GMAW and GTAW. These basic elements of the plasma arc torch illustrated in figure 1.7 as are the tungsten electrode and the orifice. A small flow of argon is simply thought the orifice to form the arc plasma. Shielding of the arc welding zone is provided by gas flows through an encircling outer nozzle assembly. The shielding gas can be ground helium or mixture of argon with either hydrogen or helium. The plasma is initiated by internal low current pilot arc between the electrode and the orifice. The pilot arc ionize the orifice gas, ignite the primary arc. Between the electrode and the base metal, the arc plasma is constructed inside the orifice around the electrode and is called transferred arc. If filler metal is used, it is filled into the arc is a GTAW process. Two welding techniques are possible with PAW process: melt-in and melt-keyhole. Melt-in technique is normally used when welding thin section in the range of 0.001 to 0.062 inch, 0.025 to 1.5 mm. Narrow weld can be obtained with PAW rather than GTAW because of the construct arc. Manual welding of the very fine section of the 0.01 in 0.2 mm under is very difficult with the GTAW process but practical with low power PAW. High current manual PAW can be done in the melt in weld in 132 to 18 inch 0.8 inch to 3 mm. Thick butt joint or lap joint can be used in joint most material. Titanium and other reactive metal can be joined using helium as a shielding gas. Generally, the operating current is 100 ampere or less. The term of keyhole has been applied to a penetrating hole at the leading edge of the molten weld pool. The weld metal hollows around the solidified behind the hole or to form the weld bed. Keyhole welds are complete joint penetration weld with high depth width ratios, resulting in low distortion. Operation with the keyhole can be done most metal in the thickness range in 332 to 38 inch 2.5 to 10 mm and up to 3/4 inch 19 mm in some titanium aluminum alloy is one of the chief difference between the PAW and GTAW process with operating current up to other 300 amperes. The PAW process required the following equipment: control console, power source, welding rod, cooling system, work clamp, and lead assembly. Shielding gas, orifice gas, inert gas, regulator, and flowme and flowmeter. The operation as equipment may be manual or mechanized. Typical costs for PAW equipment range from $3,500 to $6,000. Welder skill and training requirements are slightly greater than oxyfuel gas welding. Maintenance skill and training would be greater than for GTAW because the equipment is more complex. Out of position welding is possible and code uniform. Penetration can be obtained by PAW. Inert gas backing of the weld is normally used to minimize discontinuity at the root. Square groove joint with little or no filler metal are common, used up to 1/14 6 mm thick of more material. Welding speed range between 5 mm